Alright, now we're going to do the example problem, find the forces from the notes. So for this one, we have a block sitting on a ramp. The ramp has an angle of 37 degrees. And our goal, we're going to be finding the force of friction acting on the block and the normal force acting on the block. To give ourselves just a little bit more room to solve the problem, I drew this one on a separate page here. So I drew all my forces because that's always step one. I've got gravity parallel going down the hill, gravity perpendicular going perpendicular to the hill, normal up this way, and force of friction up that way. So step one is drawing those forces, and that's done. Step two, I've got to come up with my positives and negatives. I'm going to say down the hill is positive, up the hill is negative, and then the y-axis, upward positive, and downward negative. Step three is coming up with our components. Well, in this case, gravity would have been the only one we need to have components on, but on a ramp, it's gravity parallel and perpendicular, so that's already done for us. So from here, since the components are done, we are now going to add up our left and right things and our up and down things. I'm going to start with the left and right. So my positive right direction, I'm going to have force of gravity parallel. And then I'm going to subtract anything in the negative direction, which is my force of friction. And since I am out of arrows that go left and right, that has to equal 0. From here, a little algebra tells me then that gravity parallel has to equal my force of friction. And force of friction is what I'm looking for. Thankfully, we have an equation for force of gravity parallel. If you don't remember, please look in your notes. But it is right here, sine of the angle of the hill, which is 37 degrees. And that is going to be multiplied by the force due to gravity, which is mass, which was given in the problem as 6 kilograms, times g, which is 9.8 meters per second squared. And all that's going to equal our force of friction. So if I plug in some numbers there, I will have the sine of 37 degrees multiplied by, this might get a little tight here, 6 kilograms times 9.8 meters per second squared. And that's going to be my force of friction. So when I plug in all those numbers into my calculator, I get 35.4 newtons for my force of friction. So that's one down. Now I want to get my y direction stuff. That's my normal force and gravity perpendicular. Normal force is the upward one, so that's positive. Gravity perpendicular is the downward one, so that's going to be the negative. Add those two things together, and we get 0. Little algebra tells us that the normal force then is equal to gravity perpendicular. Just like gravity parallel, we have an equation for gravity perpendicular. That is the cosine of the angle of the hill, which is 37 degrees, multiplied by the object's mass and 9.8, which is little g. We can plug in our numbers here. Normal force is going to be cosine of 37 degrees multiplied by the mass, which is 6 kilograms, times 9.8 meters per second squared. And we plug that into a calculator, we get that our normal force is 47 newtons. And that is how we solve this one.